Good evening, everyone. The problem that we are going to discuss today is based on the topic of projection of planes. And here we are dealing with a hexagonal plane surface. So first of all, we are going to extract details or data from the description. Then we'll head over to AutoCAD. I'll demonstrate how the object has been kept with respect to HP and VP and how it would look in all the three steps. Step 1, step 2, step 3. Okay, and this is going to be fun. The 3D arrangement looks something like this, and we are going to explore this entirely in the next 10 minutes or so. So stay with me right till the end. Here we go. Let's start. One side of a regular hexagon, please note, one side of a regular hexagon of 30 mm long is in HP. So there is a regular hexagon. All the sides are equal. And we've been instructed that one of its sides is in HP. So let us simply write this. And let us just assume that that side is AB. While the opposite side, okay, so if you have an hexagon of this sort, let's say this is A, B, C, D, E, and F, then the opposite side with respect to AB is going to be this one. This side ED is at 45 mm above HP. So let me just write it down. DE 45 mm above HP. Simultaneously, it is making some angle with respect to the VP and makes an angle of 30 degrees with the VP. Okay. So please note one more thing. Here DE and AB, since they are parallel to each other, the angle made by DE with respect to the VP will be equal to the angle made by AB. Okay, I'll also demonstrate this in 3D. You don't have to worry much. Okay, so far so good. Now let's head over to AutoCAD and let me explain you all the details with more clarity. Here it is. This is the side which stays grounded in the HP, and this side, opposite side, that is DE, is at a height of 45 mm above HP. In the front view, this will be more clear. Here it is. 45 mm above HP, this way. Now, if you watch, with which principal plane or reference plane is it inclined? Sir, we can clearly see that the surface is inclined with respect to the horizontal plane. This is for sure. Therefore, your assumption for step number 1 should be to keep it parallel to HP. So we have kept it like this, right? Kept it on HP. In fact, on HP, parallel to HP, both are same things. Okay, you can just say it is parallel at a height of 0 millimeters from HP. Okay, so that is going to be your initial assumption. But a question might pop up inside your head. So why did we make this kind of hexagon? Why did we not make this hexagon? Why did we not make this hexagon? So please note, there are a few things which you need to remember, especially when attempting problems on plane projection. If the corner is grounded, this is how you begin. If the edge is grounded, edge is on HP, then this is how you begin, right? Okay. Because in the step 2, you can clearly see when the surface is inclined, one edge still is in contact with HP. However, if you had made this as your top view, and when you incline the surface, one corner would have stayed grounded. Right? That is not what our question expects us to do. Okay. So this goes your step number 2, where we can see that the side opposite to AB, that is DE, is at 45 degrees with respect to the horizontal plane. So far so good. In step number 3, as I said, DE is making an angle of 30 degrees. You can clearly see it over here. Since DE and AB are parallel to each other, so therefore angle made with VP by edge AB is equal to angle made with VP by edge DE. Both of them will be same. Now, how to implement all of these things on a plain piece of paper? That is what our objective is. Okay, orthographic projections. Have a look once again. This is the front view. There is something right here. There is something over here. Okay, it will look like a line in the front view, and that same line has to be recreated in step number 2's front view. And this is how the top view looks like. This is how the top view looks like. And this is the final top view, right? In the final top view, we've ensured that the edge is making an angle of 30 degrees with the vertical plane, and this is going to be your final front view. Think about it. It is a beautiful question. Okay, now let's move. And the solution is very simple. You just watch this. This is your first step. So I'm sure you will have no difficulty in making this hexagon. You just draw a line 30 millimeters. Let's say this is AB, and then what you can do is at an angle of 120 degrees, you need to draw another 30 mm long line, and even you have to repeat the step over here, 120. Once you reach these 2 points, C and F, the next step is to draw a construction line. Okay, this way. Now keep your compass at F, and you need to cut an arc. This arc is going to have a radius equal to 30 millimeters. The same has to be repeated with C as the center. Cut an arc. Once you get these 2 points, join all the points in sequence. That's your hexagon. Now let us take a look at it from the front. And then this is going to be point A dash, B dash, C. Behind C there is point F, C dash, F dash, and that's D dash, E dash. Let me do this. Done. In step number 2, we are going for this data, DE. D. It is exactly opposite to AB. This DE needs to be kept at a height of 45 mm above HP. So with respect to XY, in the front view, I'll make a construction line. This is that construction line at a height of 45 millimeters. Somewhere here, I am going to make a point. This is that point, D dash, E dash. It is now at a height of 45 millimeter. So with respect to this D dash and E dash, A dash, B dash has to be on XY line, since it is always on the HP. This is the condition that we need to maintain. AB will always be on HP. Therefore, its front view will always be somewhere along this line. Now, with this much as the radius, and with a D dash, E dash as the center, cut an arc along XY. This point is your A dash, B dash. Join these two. Now, with this much as the radius, with this D dash as the center, cut another arc. That's C dash, F dash. Okay. Now, we shall take a look at this arrangement from the top. Draw the lines top to bottom, and then from left to right. Right. One thing that you must note, we were instructed in question to find the surface inclination. There was no data, however, in the problem description. Okay. However, we were indirectly fed this data that the opposite side is at a certain height. If the opposite side is at a certain height, then definitely the surface would be making some angle. If you keep your protractor over here, you'll observe that the angle made with HP is 60 degrees. And now let me bring the lines downwards and then to the right. And again, if you notice, this is the line for A and B. So this is the exact location of A, and that's the exact location of B. Okay, like this. In step number 3, these two have been implemented, by the way. Step number 3, DE has to be kept at an angle of 30 degree with the VP. So assume that it is enclosed in a rectangle, and then we have to recreate this rectangle. Okay, since this DE and AB both are a part of this rectangle now, we are going to incline this rectangle initially at 30 degrees. You can also say this is also 30 degrees, by the way. Right? Let's say this is 1, 2, 3, 4. This is going to be 1, 2, 3, 4. Now, with 1A as the radius and with 1 as the center, you need to cut an arc, and this is going to give you point A. Similarly, with 2E as the radius, with 2 as the center, you're going to cut an arc that's going to give you point E. In the same fashion, all the remaining points can be worked out. And once you are done with this, draw the lines, projector lines, bottom to top, left to right, and the intersection. This is for D dash. Where is D? D, that is the precise location of D dash. Here it is. In the same fashion, all the remaining points can be worked out, and that's your final diagram. In order to add a bit more flavor, I've added some color to it. This is how it would look. Okay. Now let's also head over to AutoCAD and let me just show this to you. Take a look. We begin by making this as a, just a sec. And then this step 1 top view, step 1 front view was simply a line. Then we had, just a second, then we recreated the front view from step 1 into step 2 following this condition, and we observed that the hexagon surface has squeezed up this way. And then in step number 2 we recreated it in step 3. It's just that we kept this DE at an angle of 30 degrees, right? And then we observed this is how the arrangement looks from the front. Here we go. That's the front, top, front, top. Right? So guys, yes, that was all from my side for today. If you've got any doubt or query, write them down in the comment section below. This is Patnaik signing off. Take care and have a nice day. Thank you.